Hi there, my name is Mr. Labidis, and in this video, which is actually part of a greater series of videos I have created for the AP Precalculus syllabus, we will see together theory on multiplicity of a root. Let's quickly just mention some things. When a number x0 is 0 of a polynomial, then we know, we have seen that already, that this means that, first of all, p of x0, assuming that the polynomial was titled by p of x0 is 0. This graphically means that at x0, the graph of that polynomial intersects the x-axis, and also under the factor theorem, we know that x minus x0 is a factor of that polynomial, which means that that polynomial can be written as x minus x0 times something. Now, if that factor x minus x0 appears more than once, let's say if we have x minus 3 times x minus 3, we say that that corresponding root, the 3 in the case of my example, has a multiplicity greater than 1. Actually, it has multiplicity equal to the exact amount of numbers that factor keeps appearing. In general, if we want to normalize it in a better mathematical way, we would say that in the factorized form of a polynomial, if we can see the x minus x0 and all that to the power of n, then we say that x0, the 0, which is actually a 0, has a multiplicity of n. Let's work an example and then we will work more. Evaluate the roots. Here we already have the factorized form. So we know that under the zero product rule, it might be that x minus 3 squared equals 0, or that x plus 1 equals 0, or x squared plus 5x plus 6 equals 0. We need to solve all these separately. X minus 3 equals 0 means that x equals 3, x equals -1. And here, if we solve it with discriminant formula is the safest choice. We could see that discriminant is 25 minus 24 equals 1. x1, 2 is -5 plus minus 1 over 2. -6 over 2 is -3. -4 over 2, it's -2. So here, in general, we have the following roots or zeros. Let's call them zeros. 3, -1, -3, and -2. But notice what we mentioned about multiplicities. The x equals 3 was actually taken from the x minus 3 squared. So x minus 3 squared itself is x minus 3 times x minus 3 equals 0. This means that either this is 0, so x equals 3, or that is 0, so x equals 3 again. So you do see that the x equals 3 as a 0, although it's the same, it appeared twice. And that's what multiplicity is all about. Here, we would say that 3 has a multiplicity of 2, and everything else has a multiplicity of 1. Let's see some more. Determine the roots and their multiplicities in each of the following cases. Let's do the first one. To find the zeros, we need to make that equal to 0. So x minus 2 cubed, x plus 1 squared equals 0. So either x minus 2 cubed is 0, which means that x equals 2, or x plus 1 squared is 0, which means that x equals -1. So the zeros are indeed 2 and -1, but 2, the 0 of 2, appears 3 times. this has a multiplicity of 3, and the negative 1 appears twice. This has a multiplicity of 2. Similarly, in 9, the zeros, for instance, are 9 and negative 1. 9 has a multiplicity of 1, and negative 1 has a multiplicity of 5. And that's all. Remember that multiplicity of a 0 shows the number of times this number appears in the fully factorized form of that polynomial. As always, I hope I made things easier. If you think as well that this was a helpful video, don't forget to like and subscribe. This really helps. As always, thank you for watching, and we'll see ourselves in one of the following videos. Have a great day.